Hello students, this is Miss Dalton and today's video is on graphing piecewise functions. Okay, so when you are graphing piecewise functions, remember what a piecewise function looks like. So we have this function, f of x is equal to x squared plus 1 when x is less than 0, and f of x equals x minus 1 when x is greater than or equal to 0. So the first thing you're going to do is you're going to determine the shapes of the graph. Well, we have an x squared plus 1, we have x minus 1, so we have a parabola and a line. Parabola is anytime you have an x value squared. So this one's going to be the parabola, the bottom one is the line. And so we're going to graph both of those pieces. The next thing that you're going to have to do is you're going to have to find the boundaries of each graph. Well, both of the graphs have a boundary at 0. So we're going to draw a dotted line at x equals 0. And the top function has to be when x is less than 0, so that's going to be on the left side of that dotted line. And the bottom function is when x is greater than or equal to 0, that's going to be on the right side. So first we're going to graph the parabola. So if you remember graphing the parabola is going to have a vertex at 0, 1. Okay, this is going to be the parabola. Now, we only need the piece where x is less than 0. So we're going to cut off that piece, and we're only using that left side. Okay, now let's graph the line. The line has a y-intercept at -1, and it has a slope of 1. So here's the graph of the line, but remember we only need the piece where x is greater than or equal to 0, so we're going to cut off this piece. Now notice that that green function has an open circle because x is less than 0 on the parabola. X is greater than or equal to 0 on the line, and so notice that that beginning portion of the line is going to have a solid point. And this would be the graph of your piecewise function. All right, let's look at another one. We're going to graph f of x equals 3x plus 2 when x is less than -2. We're going to graph the function f of x equals -x when x is between -2 and 1. And then the last one, x squared minus 2 when x is greater than or equal to 1. So let's determine our shapes. We have a line, and a parabola. So the first two are the lines, the bottom one is the parabola. Now let's look at the boundaries. Well, we have boundaries at -2 and +1. So let's put dotted lines on those values. And now let's graph that first line. Okay, that first line gets graphed. It has a y-intercept of +2 with a slope of 3 over 1. And so here's our line. But remember, we only need it where x is less than -2. So we're going to cut off that piece. Notice also that we changed that point to be an open point because it's less than -2, not equal to. Then we've got our other line right here when x is between -2 and 1. So we're going to cut off those other pieces. Notice that I put a solid point when x is -2 since it says it's equal to that. And notice I put an open circle at 1 because it's just less than 1. Now let's graph that parabola. It has a vertex at 0, -2. But we only need the portion of the graph that is greater than or equal to 1. So here is our piecewise function. We're going to take off those dotted lines, and this is what it looks like. Now notice that this is going to be a discrete or a discontinuous function because there are gaps. So we're going to look at some of these characteristics. Remember that an absolute minimum is the lowest point of the graph, and if it goes on forever to -infinity, well, there's not going to be an absolute minimum. Absolute maximum is the highest point of the entirety of the graph. So remember these key words. If we look at this graph right here, the absolute minimum would be right here. The absolute maximum would be right here. It's the absolute lowest and highest point on the graph. All right. When asked for the interval of increasing or decreasing of a function, remember that you're indicating the domain values. So you will have to identify the increasing and decreasing. In other words, on this particular function, which section is increasing? We have an increasing section here, we have an increasing section here. Notice how I wrote the intervals, -3 to 0, that represents your domain values. 2 to 4, that represents your domain values as well. This section of the graph is decreasing. That would be the interval from -5 to -3. This section is decreasing as well. That would be the interval from 0 to 2. Okay, so don't forget those vocabulary words because we will apply that into the assignment. Let me know if you have any questions. Come to class prepared.